Welcome to the Deep Dive. Today we're looking at one of those big problems in live sound and broadcast.
A huge one.
Yeah, how do you get perfect audio over like a massive distance?
Yeah.
We're focusing on the Thor Broadcast F-2A-XLR-B-PHP-TXRX kit. It's a transmitter-receiver pair that promises to replace a ton of heavy copper cable with fiber.
Right. And our mission today is pretty simple. How does this thing take 4 channels of analog audio and just send it 20 kilometers down a single fiber optic cable with, broadcast level quality? We're going to get into the tech that makes it work.
Things like CWDM, FPGAs.
And maybe most importantly for the pros, how it handles something like phantom power from that far away.
Okay, let's jump right in with the most obvious advantage here. Fiber. This kit runs on standard single-mode fiber for up to 20 kilometers.
Which is just a staggering distance.
I mean, for a big stadium tour or some kind of remote broadcast, that's not a nice to have, that's essential. But distance is just the start.
Exactly. You can get a signal there, but is it usable? That's the question. Pro audio needs power and it needs control. This unit handles 4 XLR channels, sure, but the real magic for an audio engineer is the switchable 48-volt phantom power.
On each channel, right?
On each individual channel. So you can run your expensive condenser mics that need power right next to dynamic mics that would be damaged by it.
And you can control that from miles away.
That's the key. It just simplifies these incredibly complex stage setups.
So if you're pushing 4 separate audio signals, 4 different mics, down one tiny little fiber strand,
Yeah.
how does that even work?
It comes down to some really cool physics. It's a tech called coarse wavelength division multiplexing, or CWDM.
Okay.
I mean, think of it this way. Instead of needing 4 separate pipes for 4 streams of water, CWDM uses 4 different colors of light.
So it's sending them all down the same pipe, just different wavelengths.
Exactly. And what's really fascinating is that this same idea, the CWDM architecture, it's scalable. This box is for audio, but you could easily use the same core tech to add video or data or network traffic all on that one fiber.
Okay, so that solves the distance and the channel count. But the harder problem, I think, is signal quality. You're taking an analog signal and sending it that far. Aren't you just asking for noise to creep in?
You would be if it weren't for some really sophisticated digital processing. At the heart of this thing is an FPGA, a field programmable gate array.
The brains of the operation.
The custom-built brain, yeah. It's not a generic chip. It's tailored specifically for this one job. Locking onto that audio signal, handling the digital coding, making sure the timing is rock solid.
Well, what about the noise itself? The actual hiss and hum?
Right, so that's where its, quote, intelligent noise suppression system comes in. It's not just a gate. It uses these really subtle soft rise and soft fall ramps. It even has what they call simulated squelch.
So when the mic is quiet, the channel is actually quiet.
Hmm.
No hiss.
Dead silent. It also has a high-pass filter built in to kill any DC offset, which is that low-level buzz you sometimes get. It gives you a true, clean 0 point for your audio.
I mean, you pair all that smart processing with the raw conversion quality.
Yep.
I'm seeing 24-bit audio sampling at 192 kilohertz.
Yeah, the specs are serious. And what that all translates to for the engineer in the field is just confidence.
You can trust it.
You can absolutely trust it. The result is a signal-to-noise ratio of 100 dB.
Which is huge.
It's an industry benchmark, especially over a 20-kilometer run. It means no pops, no distortion, just the sound you put into it.
So it's clean, it's powerful.
Yeah.
But is it tough? Because in a stadium or a festival field, things get knocked around.
They do. And this is built for that. I mean, beyond just being stable, they built in protection. The audio ports have level 3 lightning protection.
Seriously?
Yeah, it's rated to handle a spike of up to 6 kilovolts. In a huge venue with a massive power grid, that's not a luxury. That's what keeps the show running.
And what about the tech setting it up at 3 in the morning?
They get a break. It's totally plug and play. No menus, no configuration. You plug it in, you look at the LEDs for power, signal, and fiber link, and you're good to go.
So to wrap this up, what we have here is technology that gives you pro-grade audio, a 100 dB signal-to-noise ratio over 20 kilometers, with remote power for your mics, all running on a single fiber line. That's thanks to CWDM and that smart FPGA core.
Right. And that really leaves you with a big question. If you're, say, designing a new broadcast studio or a concert venue, we know the CWDM tech can handle video, data, and networking just as easily as audio. So when does it get to the point where we stop running separate cables for everything and just merge all our media signals onto one single, super reliable fiber backbone? I think that day is coming pretty soon.